Welcome back to Man Cave Workshop. Okay, if you watch the last video in this series on this valve radio, you'll know I stopped when we started pulling out these filter smoothing caps. I think they are anyway. Because when I looked at the value, they were 350 volts, 16 UF, I think. Yeah, 16 UF. So I've just got this test leads on to sort of remember where it goes. I didn't have any in stock. Working on transistor radios, I don't carry that sort of stock, that higher voltage. I think the maximum I've got voltage wise is about 63 volts. So we ordered some and they've arrived. So I thought it'd be fun to test this one on the meter here. We've got it's a test meter that I think it measures ESR. So let's stick it on and see what it says before we start going crazy. Now I did start to change out some of the old waxy caps, but after reading a comment, I think it was a guy called Rob Tiveridge, he said stop there and don't go too fast. Because you won't know what the fault was on the radio, which, yeah, quite rightly, so I've stopped. I've changed a couple, this one down here and one up here. The one up here, when I pulled it out, I was surprised to see that it said it was a 1000 volt cap. 0.001 microfarads. So I've stuck in. I didn't have anything. The caps I've got, they're only rated to 630 volts. So I thought, it must have been there for a reason. Whether I've done right or wrong, I've put an extra rated 1 UF safety capacitor in there. I didn't want to play about with that. They must have put 1000 volts in for a reason. Again, comment if I'm doing it wrong. I can always rectify this. It'll be good for testing purposes. So there's the new. These are, turn it the right way around. These are expensive actually. They're 450 volts, 16 UF. I can't believe how expensive they are now. Things have rocketed in price, especially the axial capacitors. Anyway, we've got the old one on this testing machine. Let's see what it says. It recognises it as capacitor. So it says it's 15.76 and the ESR is 2.7 ohm. V loss 4.2. Okay, let's put the new one on and see what that reads. I'm not sure if I trust this meter. It's a cheapo meter, but it gives us a rough idea. So this says it's 16.5 UF, so it's 0.5 over. That's pretty good. The V loss is 1.1 and the ESI is 2.4. That's very similar, isn't it? Do we trust this meter? Let's try this one again. I mean, we're going to change them anyway. Let's see what it says. Let's get the other capacitance meter out and see what that says. 2.7, so it might not be that bad, that cap, according to that meter. Let's get the other meter on and see what this one says. Oh, good practice, isn't it? Okay, let's connect the cap up. So this is the old one. Connect it up. This just does capacitance, this meter. Well, where are we going? Right, this says 14.8 for that. Is it a good cap, do you think? I'm just doing this 16.3. So it has dropped a bit, hasn't it? Anyway, we're gonna get on and put these new ones in, and then we'll test the radio to see if it's made any improvement on performance, because all the radio does is hum. That's all it does. Okay, so join me back again in a minute while we'll change the caps. Now then, before we carry on, notice I've got test leads all over the place. Negative. These are the brackets that held the old capacitors to to the chassis. And obviously with these new caps being small, they don't fit very well. What I've done, I've just if you can see, I've just crimped it up a little bit, this one, with some pliers, and now it's not perfect, but it holds it quite firm. I'll crimp it up a little bit more. When it's pushed against the chassis, it does hold it in place. So I'm going to reuse them to hold these caps in. And what I'm going to do, I'm going to screw them in first, get the screws, and then solder it all up. Okay. Let's have a look here where they were. There's that X2 rated cap that I've put in. Might need a little bit more insulation there. Because if that's got 1,000 bolts across it, we don't want any bare wires really. I have to do something about that. Okay, I'll get these caps in and then we'll see how it looks. Try and keep it as neat and tidy as we can. Okay, so we've changed them to caps. It was a bit of a squeeze. And we've used the original brackets back on them. We've changed this one cap down here and this one here. So we've got the, let me bring you out here. We've got the cabinet here so we can switch it on and give it a test. Now remember, all it did was hum before. I brought out the dial lamps here so we can see them light up if they light up. Oh, the dial strings fell off, so we're going to have to sort that out. I've put the missing valve back in. Okay, let's switch it on. Let's see what we get. We're set on medium wave. Let's get the volume up. Any noise? There's nothing yet. Oh. Okay. So let me move this towards the speaker. I don't know if you can hear that, but we've still got just a hum. So we're going to have to look a little bit further into this, see what's causing this problem. What we'll do next is we'll carry on and recap all these waxes and then give the set another test. We've got some dirt on. I'm just twizzing one of the pots here. So that's some dirt. I think that's the volume and on-off switch, which isn't making very much difference at all. Let's try the other wave bands. Yeah, perhaps we should clean all the switches as well. We've not tried that yet. Well, that's it for this video. We'll just change them few caps. We'll carry on doing it. We'll get some switch cleaner in it. We'll clean it all up. We'll change all the caps and then see if we can't get it to work. So thanks for joining me again. Hope to catch you in the next one. I think we're going to turn our attention to this guy next. See what that guy's all about. Might be something to do with that hum.